Ashutosh Sharma, who worked at Enterprise DB, is going to present this. So yeah, let's go ahead. One advice, like if you have more questions, I would request you to take at the end because we have limited time.
Why is this not moving? Yeah. So hi everyone. Rushav has already introduced me. I won't be introducing myself again. So I'm here to talk about monitoring and debugging PostgreSQL. So just before I start with the discussion, I'll be sharing, I'll be just talking about my agenda a bit. So what is the agenda of this talk? So I'll be talking on these many topics. Like I'll be talking on database logs, where I'll be basically talking about how database log files can be located in Postgres database. And then I'll be talking about what are the different informations that we can retrieve from the log files. That will be followed by a PostgreSQL statistics collector process. So what is statistics collector process in Postgres and what it does, what are the different stats it collects, and what are the different tracking parameters associated with this process. That will be followed by statistics views. So there are a lot of statistics views in Postgres, but I'll be only talking about a couple of them. I mean, the most commonly used ones, for example, PGStat activity and all that. And that will be followed by wait events in Postgres. So again, I'll be talking about what is wait events, how we can do wait events monitoring in Postgres. That will be followed by PGStat statements. So how a SQL query can be profiled using PGStat statements. And lastly, I'll be talking about some useful debugging tools in Postgres, for example, page inspect and PGStat tuples. So that's the overview of my talk today. So let's start then. So where are my database logs? You know, this is a very basic question. I mean, this is something that comes into the mind of someone who is very new to Postgres. And for them, it's very simple to locate. Like there are some parameters associated with the log files in Postgres, and all we have to do is just run show command and check the settings of those parameters. For example, there is something called log destination. So what this basically tells is like where the Postgres process is basically sending all its log messages to. So it can have different values, like it can be std error, it can be syslog process, it can be CSV log, or it can be event log in case of Windows. So the default one is std error, meaning that Postgres process is sending all its log messages to the std error file. So, but then again, these log messages are finally redirected and written into some log files. So how to know the exact location of those log files? So for that, again, we'll have to check settings of some other parameters. So for example, there is something called logging collector. So when this is enabled, so Postgres process basically starts a new logger process in Postgres, which basically collects the message from the std error file and writes them into some log file, which is basically created in the log directory. But now, how to locate the log directory, like where the log directory exists, and also in Postgres, it is created inside the data directory. So we can just check the location of this data directory in Postgres. So again, we have a group variable called data directory, and we can just run show command for it, and that will show us the exact location of that data directory. And similarly, we have something called log file name, which will basically show like how the log files are named. I mean, there is a naming convention for the log files that are generated in the log directory. So this is how we can, basically track the log files and find out where the log files are basically generated. But then how to, like, what are the informations that we can retrieve from the log file? So what informations do the log file contain? So by default, these are the different informations that you can find in the log file in Postgres. So it can be general log information, or it can be, error messages, or it can be hint messages. So when I say general log information, like it can be things like you can find these sort of messages. For example, when the database system was last shut down, and when the shutdown happened, whether it was a clean shutdown or not. If it was not a clean shutdown, you would see a message like automatic recovery is happening when the database system is being started. So similarly, you can see a message, for example, if any server process got killed. Like what is, so you would find details about that server process, like what is the process that got killed and what is the query that it was executing when the process got killed. So for developers, it's very simple, like you can just attach that process to the GDB and just see what was going on in that process and how it got killed. So I mean, these are the small informations that you can retrieve from the log files. Similarly, you can find error messages. For example, if someone is trying to query a table that basically does not exist at all, or if someone is trying to connect to database which he is not supposed to. So those sort of messages which basically comes under error messages. So it can be of different levels, like it can be normal error message, or it can be fatal, or it can be panic, which basically will shut down your entire database cluster. And then you can find some hint messages as well, which are basically very useful. For example, if in your database checkpoints is occurring very frequently, so you would see a message saying that checkpoint is occurring very frequently, so you need to consider increasing something called checkpoint segments. So I mean, and those can be very helpful. Similarly, if someone is trying to query a function which wrongly, like so you would get a hint message for it saying that okay, you need to pass some parameter to this function. Or maybe you are not, you do not know the exact prototype of the function, so you need to pass so and so parameters. So you would be getting such type of hint messages for that. So whatever we saw till now was kind of like by default you will be getting those sort of messages in the log files. But if you want some advanced level messages, for example, you just want to log the queries which are running for longer time. For example, if you just want to log a query in your log files which is taking more than 20 seconds of time. So for that, again, there is a GUC parameter called log mean duration statement, which you can set to 20 seconds. And when you do that and just reload your conf file, you would be seeing that only the queries that are taking more than this much of time is being logged in the log file. Similarly, you can, if there is any, if you just want to track like if any temp files are getting generated or not. So for that, again, you can set this log temp files to some non-zero value. So this would like kind of just log if any temp files get generated by during any query processing. So that sort of, so the message related to that would be logged in the log file, would be generated in the log file. Similarly, if backend had to, if a particular backend had to wait for some LW log, so the details about that backend can also be logged if you are able to set this, like if you can set this log wait parameter to on, and this just reload the conf file. So that was all about the database logs. Do you all have any questions about that? Sorry, when you,
log slow queries, right?
Okay.
Would we capture logical reads, physical reads, basically?
Yeah, we can do that. I'm not sure whether we can do that with the help of log files, but there are certain things like we have some statistics views and all, and we have something called statistics collector, which we'll be discussing down the line. So if we enable some of the track parameters associated with that, we can track those IO timings and all also. We can do that. I think we can do it in log file also, but I'm not aware of that. I'm not sure about that. So now let us move to the next topic, which is basically on statistics collector process in Postgres. So basically, this is, I mean, as the name indicates, it's a process in Postgres which basically collects statistics about all the running backends and writes them into some files. So and it is always on by default. So like like what kind of stats it collects and what are the things that it needs to collect and write into the file. So those things can be controlled with the help of some track parameters associated with this process, which we'll be talking in the next slide. So these are the different track parameters associated with statistics collector process. So the first thing is basically track activities, which basically tells the statistics collector process like whether it should be tracking information related to a particular query, like whether if any query is being executed by a backend. So what is the name of that? Like what is the query that the backend is executing, and what is the state of a backend? Like whether it is in the active state or idle state, and when that query execution started. So those small informations, will be tracked by this stats collector process when this particular parameter is enabled, and this parameter is always enabled by default. And then the next parameter is like track activity query size, which basically tells like what should be the size of a query that can be written in the stats file. So the default size is 1024 bytes, meaning that only the query of this many size can be written. Like if there is a query which has more than, whose size is more than 1024 bytes, then that query will be truncated and written into the file, into the stats file. Similarly, we have something called track counts, which will basically allow the statistics collector process to track the access related statistics, like how many time a particular base table got accessed by the user, or index access happened, and all that. So we have a couple of more track parameters. So there is something called track IO timing. So this is what you were asking, right? How to track the IO. So you can just enable this track IO timing, parameter, and this. So once you enable this, the stats collector process will be tracking the IO related stuff, like how much time got spent on reading the blocks from the disk and all that, or writing block into the disk. But this is off by default because it can reduce the query performance because it involves some system call and all. So it's not good, to always have this on. And then lastly, we have something called track functions, which basically allows Postgres, the stats collector process to track user functions, and this is set to none by default, meaning that it won't be tracking any functions. But then it can be set to different values, like it can be set to C if you just want the stats collector process to track C functions, or it can be set to PL, like procedural functions and all. So that's about all the track parameters for controlling the stats collector process. So here is one small example where I have just started a transaction and I have set the IO timing to on. And here, and this is just to see like how the IO timing basically affects the overall query performance. So I have just ran select star from like tab 1. I've just performed select on a tab on a simple table, and then I'm trying to run it with explain, analyze, and buffers option enabled. So here you can see like the overall query execution time is 42 milliseconds, and out of that 42 milliseconds, 30 milliseconds of time was spent on IO. So you can just imagine like how IO can impact the overall query performance. But you can only get the details of this IO timing and all by enabling that track IO timing parameters. So I just ran the same query once again, but this time you can see like there is no IO timing involved, because since I'm running the same query once again, the data got cached completely, so no IO timing at all. So any questions on this stats collector process? Yeah, so for that we have statistics views. So we have statistics views. So basically, whatever stats is collected by the statistics collector process and written into some stats file. So on top of that, we have developed some functions which basically retrieves the data from there, and on top of that we have views. So we can query those views, which basically will shows all the stats. For you mean for the foreign tables and all?
Foreign tables, yeah. Non-Postgres
like if there is any query like if you are running a query for a table which basically exists on Oracle and all, and you are trying to, I'm not sure about that. Okay, so the next topic is basically on statistics views. So here, as I said in the start, I will be just talking about some statistics views like PGStat database and their use cases. So here in this particular topic, I'll be talking about PGStat database, PGStat activity, and PGStat some user tables and all. So what is PGStat database? So basically, it's a view which basically stores like database level statistics. So it'll like have one row for each database in your database cluster, and will store statistics related to each database. For example, how many at a particular time, like how many backends are connected to a particular database, or what are the DML statistics related to that database, like what are the transaction statistics, like how many transactions got rolled back in a database, how many transactions got committed, and all that stuff. So all those things you can just find by querying this PGStat database. So I have not like shown the layout and all of this this view that you can find by from the Postgres docs. So now, like how to make use of data available in this PGStat database, like what are the different use cases of it? So here is one simple use case, like we can use this, like we can query this view for finding something like, say, if I want to know the cache hit ratio, or if I want to know the DML statistics, or if I want to know transaction statistics for a particular database, I can just query this this view, and I can find the details. So here is one simple query which like I have just prepared a select query, and I have just created a view on top of it so that I can run the select on that view again and again. So here you can see, like in the query I have just omitted this template 0 and template 1 database. And since I have just one database, which is Postgres, you can see the statistics of it. So the cache hit ratio is around 95%, which is good. That means 95% of your files are already available in the shared buffer. So which is really good. And then some DML statistics, like how many tuples were inserted in this database, how many tuples got updated or deleted from this database, and then how many transactions, what are the transaction related statistics, like how many transactions got committed and rolled back. So this sort of information can be easily, can be easily known by just querying this system, this statistics view. And similarly, we can query this PGStat database for other things, like for finding how many temp files got generated and what is the size of the temp file that is being generated in this database. And if it is that means we have not set the values of something like walk mem or something to the proper value. So maybe we can increase that, because normally when you run this order by queries and all, like order by clause and also, that requires some sorting and all, for which it creates the temp files. So if your walk mem and all is not set properly, so then temp files would get generated. So if you want to get idea about that temp files and all, you can just query this this view. And similarly, for monitoring the overall database loads in your database cluster. So for example, like what is the database that is mostly being used in your cluster. So and those sort of information can be easily retrieved by again querying this PGStat database. So we have another statistics view like PGStat database, something called PGStat all tables, which will basically store information about all the tables in your system. So it can be, it can be a system table, or it can be a normal user table also. So like it will have one row for each table, where it will store like the access related statistics about a table, or like things like how many tuples are present in the table, or if the tuples are present, whether they are the live tuples or dead tuples and all that stuff. So now again, how to make use of data in this PGStat all tables. So what are the different use cases of it? So like you can use it for various purposes. For example, if you want to just know like what are the most read tables in your database, like So again, you can just query this table and query this view and find out like what is the most read table in your database, and just check things like whether the tables which is being read most frequently and all, whether it is having properly like proper indexes and all. So those things. And similarly, you can do auto vacuum monitoring also. Like this view also stores some auto vacuum related stuffs, like when the table was last vacuumed and all. Similarly, the count for number of dead tuples, live tuples, and all that can also be found just by querying this view. And also, if you want to know the ratio of index scan to sequential scan on a table, so that also you can find by querying this table. So normally, if it is a large table, it should prefer index scan. If it is not happening, then there is something wrong with the table. So any questions till now? I didn't get you. Okay. Right. That I think that you can do by querying PGStat activity. You just want that for a particular backend session, is it?
Yeah. For example, I wanted to identify some particular row procedure is actually creating a lot of transactions and rollbacks. So if I just want to monitor that particular session,
Mm-hmm.
how do I go about it? Like, do I record what was it before and record what is it after and then different?
Are you talking about a query level, or you are talking about the backend, like one session level?
So one of the particular.
So what I'm understanding is like you want to know the transaction statistics at one session level, right?
Yeah.
So I think that you can do by querying maybe I think PGStat activity.
Yeah. So that transaction, the XACT underscore commit is the total value since the last reset, right?
Yeah, right.
So that way it becomes very difficult to understand, right? What exactly happened in this session, or can we do that?
So you can filter it out with the session IDs.
Oh, okay. We have session IDs. Okay.
So I mean this is the last statistics views which I'll be talking about, and it's.
One of the slide you explained like how to identify work memory need to be increased. Can you go to that slide?
Sorry. Okay. Yes.
Yeah, here how will you identify whether to increase the work memory or not? I mean this.
No. So that I told because of like let us say if the number of temp files getting generated in this particular database is too high. Okay. So in that case, okay, if there is any if there is any backend session that is basically like if there are backend sessions basically connected to this particular database, so like you can just try to increase the work mem there.
No, actually, I mean usually we used to give very less, right? 15 MB, 20 MB like that.
Right.
Even in the previous session also I saw like I mean one of your colleague explained in that there they mentioned like 1 GB. It's like I mean every session sort operation it will use 1 GB. Am I correct?
I mean there could be some limit for it,
okay.
But I think by default the value is quite less.
Yeah,
so if you are seeing there are a lot of temp files getting generated, you can just try to increase that for that particular session.
Okay, based on the temp files you will decide, you are saying?
I mean that's what you can do, right? Oh. The temp files is right. So.
I mean work mem has many other aspects. It's not only about the temp file. So yeah, this here what he was trying to explain is like whether if there is you encounter that you have many temp file getting generated in a session, you maybe try to increase the work mem or in the maintenance work mem.
Right.
That situation.
That's what my point was. Okay, so PGStat activity is another system view, like, and I think most of you might be knowing about it. So it's mostly like it's used for analyzing like it basically stores data about all the running backends. Like it will be, so like again like pgstat all tables and all, it will have one row for each server process that is currently running and connected to a database. And what else? So yeah, so then we'll just see some use cases of it. So again, like PGStat activity, you can basically use for finding out like what are the number of query that is currently executing in your database. So again, for that I have just I have just performed a select query on this PGStat activity, and on top of that I have created a view which I am basically trying to query. So here you can see like for the database Postgres, there are currently two open sessions, out of which one is basically in the active state and one is in the idle state. So basically what I'm trying to say is like with the help of this PGStat activity and all, like you can just find out if there is any, let us say if there is any backend session which is just in the idle state for long time. So you can just consider terminating those backend sessions. So for example, like finding and killing some long running idle database connection. So this is again the same thing which I talked about just now. So here again this query just basically it is just trying to find out like if there is any backend session which is in the idle state for more than 5 days or so. So you can just consider terminating those backend sessions. So again that can be found by just querying this PGStat activity system view. Similarly, if you want to just detect some long running queries or transactions, so again you can just query this PGStat activity and that will give you the idea on what are the long running queries and all. Another thing can be like you can use this statistics view for kind of wait event monitoring. Like if you want to just know if your backend session is waiting on some events, on some LW lock and all, so again we have just added 2 extra columns in the PGStat activity called wait event and wait event type. So you can just find out if there is any backend session waiting for any LW lock or something, or any other type of lock. So just finding the block sessions, and then for other purposes also you can use it. Like if you want to know the details about the client, which is basically connected to a server. So what is the client address, like what is the host name and all of the client. So that's all about PGStat activity. Now we'll just see about wait events, which is basically connected to this PGStat activity. So wait event is something that basically tells us, yes, number of, right. See, that basically depends on what is the type of query you are running on your database. So like if the query requires some walk name space and all, and if it requires large walk name space than what is configured, then you can try increasing it. Number of connections you are telling, right? So I mean that you have to alter as per your requirement. I think that is some. That.
Excuse me, I think we can take this offline because we don't, he has enough slides to cover still.
So yeah, the next topic is basically about wait events. So basically what is wait event then? So it is nothing but kind of like event on which your backend session is currently waiting for. Like let us say if your backend session is waiting for some lock, so you will find, I mean the wait event for that backend session is going to be that particular lock on which it is waiting for. So basically in the PGStat activity view, we have added couple of columns with the name wait event type and wait event, which basically tells us like what is the lock on which the backend is currently waiting for, and that lock falls under which group. Like for example, if a backend is waiting on a wall write lock, so in the wait event column you will be seeing the actual lock name there, and in the wait event type you will see what is that type of lock. Like if it is LW lock, you would see LW lock in the wait event type column. So, and these are the different types of wait event. Like it can be LW lock if a backend is waiting for the lightweight lock, or it can be some heavyweight lock. For example, it can be a tuple level lock, or it can be a relation level lock. Or maybe if a client is just in the idle state waiting for some client to send a query, waiting for the application to send some query. So you would find that particular backend in the waiting for the wait type for that is going to be client. So similarly, it can be other things like buffer pin. Like let us say if a backend session is trying to acquire some cleanup log, and also you would see that waiting for a buffer pin. If so, that is how it is. And then so these are the different wait events. I have just listed few of them, but there are many others. So it can be like wall write lock, which is basically mostly seen because wall write is continuously happening in if it is if you run some DML statements and also. And then it can be checkpoint log or other things. So I mean, you can just find these details in the Postgres docs also. There's nothing new in this. So here is one simple use case where I'm just trying to see like, so what I have done is with synchronous commit on, I have just ran a PG bench for 20 clients and for 5 minutes of time. So it's basically in the read write mode. And so when this query is running, if I just try to see the wait event and wait event type, so you can see here like most of the backend sessions which are basically in the active state, they are basically waiting for the wall write log. So the contention on wall write log is a lot more. So I mean, this way you can just make use of this wait event type information in the pgstat activity. Similarly, if you just turn off this synchronous commit parameter and then see, so you can see here like there is no contention at all on the wall write log, because now wall write is not happening synchronously. So likewise, you can make use of this wait event and wait event type information to find the contention on different logs. So my next topic is basically on the PGStat statements. Yeah. So again, like it's another statistics view, but it doesn't fall in default category. Like if you want to use this, you have to install it separately. So it's basically a quantary module where which basically stores information at a SQL query level. Like for each SQL query, it will have one entry in the pgstat statements table, which is basically a hash table. So all we can do is like we can just install this. We have to install this, and for that we have to kind of specify the module name in the shared preload libraries in PostgreSQL.conf file. And yeah, then we can once we install it, we can just start using it. So what it does is, so there are again some track parameters which are basically linked with this pgstat statements module, and that basically helps to like kind of like it tells you like how many like what are the different things that can be stored and all and can be tracked by the pgstat statements module. So for example, there is something called pgstat statements.max, which basically tells you like what is the maximum number of entry that can be stored in the hash table in pgstat statements hash table. So by default, I think it's 5,000. If it exceeds beyond that, then maybe you would see wraparound happening. Then there is something called track. PGStat statements.track, which basically tells like what are the type of like query that needs to be tracked by this pgstat statement. So like whether it should be tracking only the top level statements, or if it is having some nested statements, should it be tracking those nested statements as well or not. So by default, it is just tracking the main query. It won't track the child query and all. And then there is something called track utility, which will basically specify, like which basically tells whether the utility statements, like create and delete and truncate and all those statements should be tracked or not by the pgstat statements. And then the save, so basically this is the option, like, so as I said in the beginning, like pgstat statements normally they store details about a query in the in-memory hash table. So when you shut down your database cluster, so should this pgstat statements save the content of in-memory hash table into some temporary file or not? So this option is by default it is on, meaning that when you shut down your database system, all the queries and its details will be saved in the temporary file, and when you restart, again the table will be recreated and the same data will be loaded into the hash table. So this is one, and another thing is, like in pgstat statements you would see like it would store a value in the normalized form, so that for example here you can see like I have just performed insert statement on a table tab 1, and then I have specified like the values and whatever value it is. So you can see here the values, the actual value which I entered in the in this table, like it is coming in $1 form. So this basically is good from security perspective, I guess, from data security perspective, as well as it also reduces the number of entries in the hash table. So you can find different information by querying this pgstat statements, like the query itself, what is the query start time, what is the total time taken by the query, whether this query involved any IO or not, so all those informations. So for example, like how many times a query was called, what is the total time a query took for the execution, and what is the shared buffer hit ratio, like so here, like for example, out of the 7 blocks that it read, 6 blocks were already found in the shared buffer, just one it had to read from the disk. So it's around the hit rate is around 85%, which is good. And similarly you can find like what is the total time spent in reading and writing to the disk. So, and then like I have just written a small query which is basically used for monitoring the query performance. So I have just started a PG bench, and then so you can see here the output of this pgstat statements. So this is basically the output of my previous query. So here you can see like the second query, right? I mean, which is basically the copy from command. So here you can see that this query is basically taking most of the time. It just got executed once, and the reason is very obvious. You can see here like the shared blocks read happening for the second query is quite high, and that's the reason this query is taking quite longer time. The first query is, I mean, it is highest, like it is first in the list, but still since the number of calls, number of times it is executed is quite high, we can't consider that query to be expensive or something. So that's all about pgstat statements. You all have any questions about that? Sorry, what did you say?
So he's asking, is there any tool which can collect all this data and give the summary information?
Oh, you mean a tool like pgstat statements? Some other?
So GUI or something.
What is it?
GUI. Report.
I am not sure about that. What is that? PG form? Oh, I think there is something called PG Badger also. I think that also you can use. Yeah. PG Badger is there, I think, but I haven't used it. I'm not sure about that, yeah. Okay, so this is the last topic of this talk here. So it's basically on some of the debugging tools in Postgres, and it's very useful if someone is trying to, if someone wants to debug things at a page level and all. So you can use this tool. So here I'll be discussing about a couple of tools like page inspect and pgstat tuple. So Page inspect is basically used to see what are the changes happening at the page level. So again, it's an extension model which you need to install by using create extension command in Postgres. And once you install it, so you can, and it has some set of functions, so you can just make use of those functions to see the changes that are happening at the page level. So for example, I have just created a table here with primary key on one of its column, and then I have just inserted a value in that table. So I just ran the create extension command, and then I'm just trying to, with the help of this heap page items function, which basically got created while installing this page inspect module. So with the help of that function, I'm just trying to see like what are the changes that has happened in this page. For example, the tuple that so I can just see like the tuple that I inserted, the value 10, like at what offset it got, basically that tuple got inserted. For example, you can see here at LP_off, it will show you that at that particular position in the page 0, it got inserted. And what is the transaction that basically inserted it, and about the details about the LP, that line pointers and all. So you can use this page inspect for this purpose. Similarly, if let us say if you ran update query on the table, so if you just want to see like what happened with the old tuple and where the new version of tuple got inserted. So you can see here like what are the xmin, xmax field of the new and old tuples, and what is the offset at which the new version of tuple got inserted. So again, you can just query this heap page items function of page inspect and get the details. Similarly, like so basically when I updated the tuple, I mean the old version of tuple still exists in the page, and what if I run the vacuum on the page? So when I run vacuum, you can see here like the page got compactified. In the previous slide, you would have seen like the new version of tuple was existing at this 8128 offset. Now when I ran vacuum, the page got compactified. So you can see here that the new version of tuple, which was basically at the different offset, now is moved to some other offset like 8160 or something. So I mean this sort of information, like the changes that is happening at a page level and all. So those things you can easily find out by querying this functions by using this page inspect module. So whatever I did so far was for the base table. If you want to see like changes happening at the index pages, that too you can do by querying some of the functions which are related to indexes. For example, there is something called BT page items. So you can see here like what is that tuple in the index page basically pointing to and all that. So the last topic is basically on PGStat tuple. So this is again another extension module in Postgres, which basically shows the statistics at a table level, like what is the size of a table, what are the number of tuples that exist in a table, and what are the number of live and dead tuples in the table, and all that stuff. And particularly, it can be used to find a bloat in a table. Like if you want to just find out like what are the bloated tables in your database, you can just make use of this PGStat tuple module and just find it. So here I have just shown a simple example here. I have just done a pgbench setup at scale factor of 10. So this basically creates a table pgbench_accounts whose size is basically 128 MB. So what I'm trying to do here is just trying to create a bloat in this table artificially and see if that bloat can be detected with the help of PGStat tuple. So I have just started a transaction with isolation level of repeatable read, and then just performed select on that table. And then in the second session, what I'm trying to do is I'm just trying to start a pgbench test in the read write mode. And you can see here after this pgbench test got completed, the size of this pgbench accounts table now has doubled. So in the earlier slide, like it was 128 MB. Now you can see here it's 256 MB. So that means the table is really bloated. So what you can do is, I just performed vacuum analyze such that the old tuples gets deleted, gets removed. And then with the help of this PGStat tuples, I'm able to find out like whether this table is really having a lot of free space and all. So you can see here in the approx free percentage, you can see here like around 50% of the space in the table is free, which means this table is bloated. So that's all. I hope I could finish in the time.
questions if anyone have.
Sorry, I didn't get. What are the?
All these extensions that we add, right? They ultimately get intercepted by the normal calls that we make to all the lot of queries.
Can we take this after this? I'll just come there. Huh?